Hey everybody, here is a homework problem that I wanted to talk about because it has uh, decimals, and I wanted to show you an example of what we've been doing with decimals. So I'm going to come back into this. I'm going to click on this to get the data. So here's our data from this. I'm going to copy this. So it says full data set. I'm going to copy this and just click on open in Excel. All right, and then this is my my data set. So it wants me to start with a lower class limit of 123.7 is what it says in the homework. If I did equals min and I went through all of this, that 123.7 is the lowest value, okay? But this actually specifically tells me what class width to use, 0.2. So what I want you guys to understand is when we did what we did in class, that was in general in practice. If you don't have any idea, what to make your class width, you determine how many classes you want, and then using that and the min and the max, that gives you your class width. But there's going to be a lot of times in your homework where it just says, hey, do this, make this your class width, and obviously that would override it. Okay, you use what it tells you to use so you get your numbers right. So following along with the procedure, we don't need to find the min and the max and all that, but we do want to start with the smallest. All right, so we're going to do our lowers and our upper, and again, you can label these whatever you want to. My lower is, for the first one, they want me to use that 123.7. All right, and they want me to use a class width of 0.2. I'm going to go ahead and put that down here. I don't need that here, but my class width, I'll just call it CW. That's going to be 0.2. And that, let me right align that, I'm going to left align that. I just want to have some gap between these values and these numbers here. But remember, this is the class width is what we add from the lower to get to the upper, okay? And if you look at the table that they're wanting me to make, well, they tell me there I want 5 classes, but I can say I want 5 classes there. Alright, so I'm going to do like we did before. I'm going to add the class width to these numbers above it. So 0.2 is my class width, and I need 5, so there's 2, 3, 4, 5. Now here's what I was talking about in the last video, that when these are, let me make all of this a little bit bigger so you can see. When these are decimals, instead of subtracting 1, well, I'm not going to subtract 1 and make this 122.9. That wouldn't make any sense because that'd be smaller than the lower limit. I'm going to subtract the last digit of precision that I have, which is the tenth. So I'm going to subtract a tenth, and I'll have 123.8. All right, and then to that number for my upper limits, I'll add the class width too. All right, and I'll go all the way down, and these will be my upper and lower limits. All right, remember, once I have the upper limits and I have the data set, this is actually the data set here. This is the days corresponding to it, but this is the actual data set that we're going to do the frequency distribution for. Once I have the uppers in the data set, I can do the histogram. So I'm going to go to data analysis, kind of off the screen there, but again, histogram. It wants to know where's my input range, that's my data. It wants to know where's my bin, that's the upper limits. And it wants to know where to put it. I'm going to tell it to put it right there. I'm going to skip, I always skip one from the upper limits. I'm going to click OK. And then there is my frequency distribution. I'm going to double click, and I'm going to make them not overlap. So again, just to make the frequencies, again, I can do like a 2% just to give a gap in there to separate the bars. But there's what it looks like. I don't necessarily need to do this. What this is going to ask me for are all these values. They're giving me that one, and then these frequencies. So I can now put those in straight into the homework problem from there. All right, I transferred those values in here. I'm gonna click check answer. It says nice work, way to go. And that's that's my frequency distribution. Again, it came directly from Excel. When I got my upper limits, I got my data set. I created the frequency distribution. There's what my histogram looks like. It's at that bell shape we talked about in class. The next question it asks, does this appear to have a normal distribution? Yes, because the frequencies start low, reach a maximum, become low again, roughly symmetric about the maximum frequency. That's perfect. All right, no, it does look bell-shaped. No, it does look bell-shaped. So this is the only other possibility, yes, because the frequencies are roughly equal across voltage. That's not true, because roughly equal across voltage classes, if you remember from our discussion, that would be what we call the uniform distribution, that they all came up about the same height. That was that last example I gave you. So this is our answer. This is what a bell shape looks like, and it's also what our histogram looks like. It is that bell shape. So there's our answer. And anyway, I just wanted you to see how to deal when it's a decimal in there. We don't always have whole numbers that we're working with. The smallest value and the maximum values from this data set were very close together. So you know, there's only a 0.9 difference between the lowest number and the upper number. So in that case, we're going to be dealing with decimals in our data set, and we just accommodate the procedure for the types of numbers that we'll deal with. Okay, so instead of subtracting 1 from this point to this point, we're subtracting 1/10 because it's the smallest place value we have in the data set.